Hi everyone, my name is Shaira binti Ibrahim. My matrix number is 22003096. This video is about how you can grow your own crystal at home by just using the salt. And first thing you have to know is the ionic attraction and electrostatic forces between sodium chloride. Sodium chloride forms crystal because the sodium ions and chloride ions are held together by electrostatic forces, and it is also called ionic bonds. Sodium lost one electron to become sodium ion, and chlorine gains one electron to become chloride ion. The sodium ion and chloride ions, now oppositely charged, attract each other with a strong electrostatic force. This attraction is the driving force behind the formation of sodium chloride crystals. In a liquid or solution, sodium ion and chloride ions are separated and move freely. However, when conditions change, like the evaporation of water or cooling, this ion begins to bond and align to form a regular repeating pattern. Next, we will discuss about the structure of sodium chloride. Sodium chloride crystal is made up of sodium ions and chloride ions. Sodium chloride crystal is a face-centered cubic closed-packed structure. The chloride ions, being comparatively larger in size, occupy the corner and face-centered positions. The sodium ions, being smaller in size, goes to fill up the voids. Thus, sodium ions occupy the octahedral voids in cubic closed structure. On extending the structure, we will see that each chloride ion is surrounded by 6 sodium ions, while each sodium ion is surrounded by 6 chloride ions. So the coordination number is 6. Now let us calculate the total number of ions per unit cell. The total number of chloride ions per unit cell is equal to sum of chloride ions at corners and at face centers. The total number of chloride ions is equal to 8 corners times 1/8 per corner plus 6 faces times 1/2 per face is equal to 4. The total number of sodium ions per unit cell is equal to sum of sodium ions at the 12 edges and 1 at the center of cube. The total number of sodium ions is equal to 12 edges times 1/4 per edge plus 1 ion in the center is equal to 4. Thus, the unit cell of sodium chloride contains 4 chloride ions and 4 sodium ions. For crystal to form, the substance must first become saturated. This means that the solution can no longer hold all the dissolved ions because it has reached its maximum solubility at a given temperature. In the case of sodium chloride, when a solution becomes saturated, the ions in the solution start to come together to form the first small clusters or nuclei of sodium chloride crystals. This process is called nucleation. These tiny clusters serve as the starting points for the growth of larger crystals. The sodium ions and chloride ions naturally arrange themselves in the most stable configuration, which is the face-centered cubic lattice. This arrangement minimizes the electrostatic energy of a system, as each ion is surrounded by 6 oppositely charged ions, maximizing the attractive forces while minimizing repulsive forces. The first thing you have to do in order to grow the sodium chloride crystal, we need to prepare a supersaturated solution. The first step is to heat a pot of water. Heat the water until it begins to bubble. The solubility of salt increases greatly with temperature. Step 2. When the water starts to boil, we can start to dissolve the salt. The amount of salt that needed depends on the amount of water you use. Keep adding and stirring until no more salt can dissolve into the water. Then slowly pour the salt solution through the filter to ensure there is no salt grains. Pour it into another container to see the result.